Morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up 126 is on the screen. That shouldn't take you long. Let's get cracking, people. Today we're moving on to another section of properties with the logs. Make sure you stay focused, people. Let's go. Okay. All right, y'all ready? Warm-up 126. Here we go. Number 1A, answer. 1 over 16. 1B, answer. 8. 1C, answer. Let's see, 49, that's square root of 243, I believe. Hands if you got that. Yes, all right. Number 2, 2 to the x over 8. Number 3, we got 9. Yes, so far so good. Let's go to number 4 with our trig functions. Let's see. We got sine of angle B. Sine angle B. Here's angle B. So I'm looking at the triangle from over here, from this view. That way. So, according to that, sine is opposite over hypotenuse. My hypotenuse is along this side, which is this one. So what side is opposite to angle B? Tell your neighbor, what side is opposite? Gabriel, what side is opposite? 8 over the hypotenuse 10. If we simplify that, that's 4 over 5. Let's go to cosine angle B. Cosine is adjacent over hypotenuse. What is that? Adjacent over hypotenuse. What is our fraction, Caesar? 6 over 10, or in other words, 3/5 if we reduce it. Tangent angle B, opposite over adjacent. Opposite over adjacent. What's our fraction? Let's go with Elijah. Eight over 6, which is 4 over 3. All right? And I'm including the unit circle and giving you time to set it up. Remember, start with these 3 and then just project the points all the way around just by changing the signs depending on the coordinate that you are, on the quadrant. All right? Thank you for sending that in. Copy the agenda, please. Warm up 113. Warm up 126, my bad. Warm up 126. Done. Logarithmic functions. Today we're going to wrap this up with some more properties. And tonight's home plate play sheet 16.1 AB, numbers 13 to 21. You'll see those in a little bit. Copy that. The code to access your home plate tonight, RD2IM. RD2IM. Write that down, RD2IM. All right? Last night's home plate were 1 through 12. Go to Canvas, turn that in. There's a new module titled Logarithmic Functions. Go in there. It should be in there. Tonight's home plate is these. There are only 9 of them. And we're going to cover these properties today. So, after it's turning your home plate, get a Cornell note ready, please. I'll give you some time. Go. All right, here we go. I can simplify logarithmic functions. I can simplify logarithmic functions. So we already know what log functions are. We know what they look like for the sake of time. And what is so specific about functions that are logs? What would you tell someone so that they can distinguish a logarithmic function, Mario? That it has what? The word log, yes, it should say log. All right, we went from log functions to exponential and backwards. We also did some rules to remember that if the base is the same as a given number, and the given number has an exponent, then the answer is the exponent on the given number. So look at this one, log 3, base is 3, the given number is 3, and the exponent is 4, the answer is 4. Another rule, if we are given a log with a particular base, and the base is the same as the base of the given number, and the given number does not have an exponent, the answer is 1. Like here, base 2 on the log, base 2 on the given number, there's no exponent, the answer is 1. The last one, if you have a log to a particular base and the given number is 1, automatically the answer is 0. Like here, log base 10, given number 1, therefore answer is 0. From there we got into the product property of logs. We did this one yesterday, look up. And what did we check first? To see if they have the same base and if it's addition. If it did, what did we do with the given numbers? We multiplied. And we came up with this. Once we got our simplified version, we said solve, we set it equal to y, change it to exponential, find the same base, find the exponent, and we solve. We did another one like so, and so on and so forth. From there we got into quotient property of logs. What does the quotient property of logs say? Well, that if both logs have the same base and we're subtracting, therefore we divide the numbers, such as this one. Same base, yes. Subtraction, yes. So what do we do with the numbers? Divide them. So here we go. Can we simplify this fraction? Yes. Divide by 8 top and bottom. We end up with 1/4. From there we solve, setting it equal to y. Make sure they're the same base on both sides, and we solve for the exponent. From there, we're moving on to this one. Copy this one on your notes, please. Power property of logarithms. Power property of logarithms. Power property of logarithms. Oh, sorry. And what does this property say? Well, it says this. If we are given a log to a particular base, and the base is different from the given number, different. Yes, it is, Mr. Q. And the given number has a particular exponent. Well, we can rewrite this by bringing the exponent of the given number to the front of the log to multiply the entire log. And the others remain the same. So once again, what does it mean? If we have a log to a particular base, the base is different from the given number, and the given number has an exponent, we bring that exponent to the front, like here, to multiply the rest of the log. Pretty straightforward. So, let's do one together. Here we go. Example 3. Copy this one. Log 4, 64 to the third power. Log 4, given number 64 to the third power. Let's see. This is base of 4. Is that different from here? Yes, Mr. Q. So, tell your neighbor what to do with this exponent of 3. What do we do with that exponent? Tell your neighbor. What to do with that exponent, Sean? Yeah, you bring it to the front. So, 3 times log 4, 64. From 1 to 5, I'll come to where you have to write there. 5s, right? Okay. All right, writing utensils down, look up to the screen. Here goes the next step because we need to simplify this as much as possible because at the end it says simplify. What do we do next, Mr. Q? Well, next, look up. We want to make sure that this has the same base as that. So, check this out. I bring down the 3 again. I bring down the log 4. And I write 64 in base 4. Question. 4 times itself, how many times gives me 64? Let's find out. What is 4 times 4? 16. Times 4, 24. We got 2. That's 64. How many times did we multiply the 4? 3 times. All right. Now, for those of you that don't see it, here goes 1, 2, 3, 4. Oh, not that 4, my bad. 3 times. And we write that right there. Okay. So, with that said, we're almost done. Look up to the screen. I want you to pay attention to this portion right here. Didn't we have a rule that said if the base of the log is the same as the base of the given number, tell your neighbor, what would this be? What would you write here by itself? What would we write there? Joseph, what would we write? If the base of the log is the same as the base of the number and the number has an exponent, what do I write here? Help him out, Kelly. If the base of the log is the same as the given number and the given number has an exponent, what do I write here? Okay. Ashlyn? 3. That is correct. Write that in there. 3. The answer for this right here is 3. If these are the same, the answer is the exponent on the given number. So, now that we have that, we bring down the other 3. So what is 3 times 3? That is 9. That is the simplified expression. Whew. All right, let me send you a screen so you can send me your notes. All right, let's do another one. Example 3Q, copy this one. Log base 3, 81 to the 5th power. Log base 3, 81 to the 5th power. That's very similar to the one we just did. See if you can do that one by yourself. And I'll send you the screen so you can send me your work as soon as you're done. Copy and go. All right. Here it goes in case you are falling behind once again. What do I check? Well, first, Mr. Q, I check this. That's different from this. So that means I take this, the exponent, and move it to the front. Okay. So then I end up with 5 times log base 3, 81. From there, bring down the 5 times log base 3. We need to write 81 in base 3. So, find out how many times. 3 times 3, that's 9, times 3, 27, times 3, that's 81. So how many? 1, 2, 3, 4. So, 5 times. Is this the same as that? Yes. So that means the answer is 4 for this section right here. So 5 times 4 is 20. Hands if you got that by yourself? Yeah, we got this right. All right, let's do another one. Copy this one. Example 3 super Q. We got log 2, 64 to the 6th power. I'll send you the screen so you can send me your notes. Go. All right, so from 1 to 5, how comfortable are you so far with that property? We're good, right? So power property. And why is it called power property, Mr. Q? Well, because we start off with a power. The exponent on the given number is also known as a power, and we send that to the front. That's why it's called the power property. Power property. Okay, so we're good with that, which brings us to the next property. Oh, I have one more, my bad. Last one, sorry. Example 3 mega Q, log 6, 36 to the 7th. And send that in as soon as you're done. Next one. This is our last property for logs. Change of base property of logs. Copy that one, please. It reads, if you are given a log with a particular base and a given number with a different base, you can actually rewrite this as 2 logs with different given numbers. Copy that, please. All right, we good? So, with that said, let's go to example number 4. Copy this one. Log base 2, given number 3. Log base 2, given number 3. All right, let's see. The base of the log is 2. The given number is totally different. There is no exponent on the given number. Okay, so what do I do now? I make a division using both of these. So I'm going to do log 3 over log 2. And this one actually is done with a calculator, so we're going to approximate the answer. So do me a favor, open up another screen. Let me go to, open up a new tab, and let's go to Desmos.com. Desmos.com. Go all the way down to the bottom to Scientific Calculator, down here, Scientific Calculator. All right, so what are we looking for? We're going to type in log 3 divided by log 2. So to do that, look up. Here in your Scientific Calculator, you're going to go to the word function to find the function. Tab on log. Type in the number 3, close parentheses. Do the slant tab on your keyboard, or you can go to the here to the main and do divide by. Go to function again, log, and now it's 2. Is that correct? It was log 3 divided by log 2. All right, so what is it? 1.58 approximately. 1.58. All right, now that we know how to use this, let's go to the next one. Do this next one by yourself. Example 4Q. So example 4Q is log 5 or log base 5 given number 7. Rewrite and then send me your approximation for that one, please, as soon as you're done. Bye. All right, so once again, if we are given a log with a different base from the given number, we make that into a division, log 7 over log 5, and that was, what was it, 1.21? 1.21, approximately. From 1 to 5, I'll come to provide you with change of base property. All right, 4 or 5, okay. So, that brings us to the end of properties for logs. Now check this out. This is all we covered on the log properties. Just to recap, if we have a log with a particular base and the base is the same as the given number, the answer is the exponent on that given number. So the answer for this is n. When we are given a log with a base the same as the given number doesn't have an exponent, the answer is 1. When we are given a log with a particular base and the given number is 1, the answer is 0. And then yesterday we did product properties, quotient properties. Today we covered power property and change of base. All right, so for all those properties, how comfortable are you with all the properties for logs from 1 to 5? Where are we at? 5 fours, 5 fours. Okay. So with that said, let me send you the home plate to your screen so you can get started with that. You should be able to finish it before you leave. I mean, some of us, because some of us are already leaving. And there it is on your screen. The rest of you following on YouTube, make sure you put some practice in. See you guys next time. Peace.